Welcome back to our integration series. If you are new here, the playlist with all of the videos is in the description down below. It will also appear in the end of this video, so you can take a look. Okay, today we have the following integral. It's x times e to the square root of x dx. And I think most of the subscribers, they already guessed that we'll use substitution to get rid of square root of x. Okay, we have, let's say, y is equal to square root of x. Then we can just write that, okay, y square is equal to x. And now let's compute dx. dx will be 2 times y dy, right? Please note that the domain of this is x is bigger than or equal to 0. Also note that y is greater than or equal to 0 because of this. And so we won't have any problem in writing this equality. Actually, it's usually absolute value of y, but in this case we can just write y here. But we'll do this in a further step. Let's take a look. Okay, now this integral is equal to y square times e to the y, as I mentioned earlier, because it's a square root of y square. And dx, as we computed earlier, it's 2 times y dy. So in the end we are left with an integral 2 times the integral of y cubed e to the y dy. Now this is a kind of a standard integral, which is like we have a polynomial function to some degree and exponential function. We will apply integration by parts here multiple of times. I believe 3 times. So let's do so. First we'll take u as y cubed, then du will be 3 times y squared dy, and equivalently we took dv as e to the y dy, and e to the y does not change under differentiation nor integration, so v will be e to the y. Our integral becomes 2 times, well, let me write here what we want to obtain is we have uv minus v du, right? Yes. Okay, now we have y cubed e to the y minus an integral of 3 times y squared e to the y dy, as expected, right? Now we'll need to apply integration by parts one more time, but beforehand let's just write our previous expression in a more clear way, which will be 6 times an integral of y squared e to the y dy. Okay, now we need to compute this gentleman here. It's done in a similar way. We first just rewrite what we have before, cube e to the y minus 6 times, well, I won't write the formula for integration by parts. Let's just think in our head as I did in a couple of earlier videos. Actually, I do this all the time. It saves the space and time. Well, the y is the function we'll differentiate later on, so because of this, first we need to find the antiderivative of e to the y, which is e to the y. So we have e to the y times y squared minus an integral of, we just copy e to the y and differentiate y squared, which is 2 times y dy. That's it. Great. Now we just rewrite what we had before. It's 2 times y cubed e to the y minus 6 times y squared e to the y plus, well, 6 times 2 is 12. 12 times e to the y, well, y times e to the y, just for the sake of convenience. Now, finally, we need to compute this integral. We'll use integration by parts again one more time. I'll just copy this and paste it here. Now, plus 12 times, again I'll use just a short form of integration by parts. I'll just think in my head that it's the function we'll differentiate later on. It's the function we need to find an entire derivative of. So first we just rewrite our function. It's the entire derivative of the other one minus an integral of this entire derivative times the derivative of our initial function, which is 1. So I'll just write dy here. Okay, we are in our final steps. I'll copy again this, then I'll add 12 times y e to the y here, then I'll subtract the 12 times integral of e to the y dy, which is again e to the y and some constant c, minus 12 times e to the y and some constant c. It's not exactly the c that came from this integral, but since it's arbitrary it doesn't matter. Okay, here we are actually done with our problem. Now all that remains is to substitute it back. Remember, we had here that y is actually square root of x, so let's clear it up. It's 2 times square root of x cube e to the square root of x minus 6 times square root of x squared e to the square root of x plus 12 times square root of x e to the square root of x minus 12 times e to the square root of x and plus c. Now it's over, it's our final answer, but I'll just write it in a more neat way. We'll just write e to the square root of x out of the brackets and write 2 times, well, first square root of x cube is just x times square root of x. It's because x is bigger than or equal to 0. We can just write this. Alright, minus 6 times just x plus 12 times square root of x minus 12. Right, let's quickly check if we did everything right. Yes, we did, and plus some constant c. Okay, this is our finalized answer. If you have any questions, as always, please feel free to write them in the comment section below. It's our problem, a quick review of what was done, and yeah, see you in the next videos. Bye.